Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about the Black Art of DevOps. DevOps has been around for some time, and there's been a lot of promise of the huge benefits of DevOps. But a lot of times we don't truly understand all the terms, the common terminology in DevOps, and we get ourselves wrapped around the axle of the wrong thing. So today on the episode, we're going to talk about some of the common DevOps terms, where DevOps fits in your organization. Is it a position in your organization? Is it a cultural shift? There's lots to talk about. First, let's talk about where does DevOps fit in your whole infrastructure, digital transformation infrastructure that you have. If you take a look, let's start at the bottom of the normal stack. Normally, we have a physical layer on top of your physical layer, which could mean a cloud, or it could mean your data center or your IoT devices or legacy infrastructure that you have. On top of that, I normally have a software-defined infrastructure that abstracts away the complexity of managing the individual pieces of hardware. On top of your software-defined infrastructure layer, I have my service management layer, which includes the container ecosystem and virtualization. I have a distributed information management layer, which includes your data plane, data lakes, everything that managing your data. And then on top of that, I have my application layer. Now, inside the application layer, these are services that your application developers use, and right at the interface between your application layer and your data management plane and your service management is your SecDevOps or your DevOps toolkits. Now, these toolkits also include security aspects and identity aspects. Without including security and identity in that SecDevOps, then you're not going to have a secure way of continuously integrating and deploying your products. So let's take a look at what's going to feed your SecDevOps before we get down into the SecDevOps. So let's take a look more at the application and workload layer inside your architecture. At the very top, we have workloads. This is what happens to get work done for your business. And there's three major types of workloads that are out there: event-driven workloads, procedural workloads, and what I like to call kind of a hybrid of the two, which is a GUI or UI-driven workload. This is how organizations work to get things done. A simple example of this for an event-driven workload would be a PO order arrives into your system. It's an event that happens. All of a sudden, a bunch of other things start happening. Now, they can happen automatically, or people can be involved. There can be sequential steps, parallel steps. There could be interaction with humans and automation and interaction with several different applications or subsystems in your company. The key here is that we understand that there are these workloads at the top. Now, there's a lot of workload automation tools that are out there. Some are all written by scripting things. Some are using robotic process automation, which are more GUI and UI driven. There's lots of great tools out there in this space. Those tools actually work on the automation of services underneath. So your workloads drive service interaction. Now, I can take services and break that down into categories as well. I normally break services down into three major categories. Applications, which are full-blown applications, off-the-shelf type of things that you're used to using, like Word or Excel or an SAP application, something like that. And there's also complex services. Now, complex services are not your typical applications. They are built for a specific service. A complex service could be like a mean stack, where I've got Mongo, I've got Node.js, I've got a web front end on that as well. That's a complex service. And then I have a simple service. A simple service is one service running. For example, MongoDB. Great example, simple service. It does one thing, it stores the database. The complex service is bringing those together. Application may consist of multiple complex services, or it may just have a simple service underneath it. A complex service is made up of multiple simple services. Now, a new category, because of the growth of AI and ML, a lot of our applications or services don't really do much without a model attached to it. So we've added AI models into this service layer, and we treat AI models much as we would treat a simple service. It's a bundle. It can typically reside in an image by itself, and it can be versioned by itself and can be passed around just like a simple service can be done. We understand the workloads and the services. Now let's look at what a typical developer does every day. They start a new project, maybe not every day they start a project. I hope not. That means they're not getting things done. They're just starting things. Let's say that they've been working on a project. They write some code. They check that code in. But hopefully, before they check that code in, they're building it on their laptop or on their workstation, wherever they're doing their work. Maybe they have a VM up in the cloud and they're doing their work there. They run their little tests to see, hey, yeah, my functionality is working fine. Check in my code into GitHub, for example, and boom, a CI/CD, continuous integration, continuous delivery pipeline kicks off. And it takes that code and it runs security checks against it. It may even run lint, which is making sure they follow the style guide. It'll run static analysis, dynamic analysis. There's a lot of tools out there that it can run on that code. It will check for security holes. There's a whole bunch of really cool things. When it passes those, it will typically check it into an integration branch where other people on the development team can grab that data, grab that new service that they've developed, and start working against it and using that service and integrating their code in with that first developer's code. Then, when everything's all hunky-dory and things have passed their tests, they will then push it out into a test stage of testing that service or complex service or application. And once that passes all the tests that have been prescribed for it, it will then push it off into production. Now, this is a typical CI/CD pipeline. These pipelines have been around for decades. They've been scripted, they've been automated, they've been generalized, they've been specialized. They've been around for some time. And luckily, we've seen a consolidation in this industry where now we're starting to see only a handful of different ways of describing pipelines, where before everyone was spinning their own, everyone was creating their own, which made it very complex and error prone. Now, to understand how we've kind of come up to this point where now these pipelines are more standardized, let's take a look at what a normal DevOps stack looks like. Because the pipeline by itself is not enough. That's just one element that's there. Other elements that are needed in order to have an effective DevOps stack is a registry or repository. And we'll talk in more depth about there's different types of registries and repositories. But the best thing to think of is these are a versioned repository to keep artifacts that are generated during the CI/CD pipeline, as well as inputs into the CI/CD pipeline. So running a CI/CD pipeline without a registry or repository is pretty much worthless because you're generating something and it's not going into a well-known place that can be used over and over again. So registries are important. Another important aspect is an automation framework. This helps alleviate the people being in the middle of running tests or running security checks or promoting builds from one stage to another stage. You want that to be as automated as possible. So investing in a good automation framework and training your SecDevOps teams on that is important. Again, tools are out there. They're very mature, and there's lots of training available out there. Another concept that most people don't think about, they kind of do it innately, but they really should think about it and strategize and architect it, and that's environment management. Most people just stand up a dev environment and it just grows over time organically, or a test environment and it grows over time organically. And production, right? We all know about production environments. If you manage and you architect your environments appropriately, you should be able to change policies in those environments to affect the way that the environments are working. And you'll get more reliability, repeatability, and all the ilities that we're always talking about. Now, another key aspect underneath this is a security profile. You should be able to have the ability to define security profiles such that they can be used in multiple environments and across multiple application stacks. That's a key aspect that you want. Sitting on top of all of this, as you've noticed, I haven't mentioned infrastructure yet. In the ideal world, we would have a global infrastructure that we could run these environments and these CI/CD pipelines anywhere. And ideally, that's what we want. We want a multi-hybrid cloud orchestrator that can connect IoT, public clouds, legacy, and private clouds all together that look like one place where I just run my CI/CD pipeline. I run my tests across multiple IoT devices, in the cloud, in legacy, wherever it is. And when I go to production, it can lay down my services that I want across any of that infrastructure and tie them all together in a nice tight bow that's pretty and easily delivered, and everything's perfect all the time. That's the ideal world. Let's talk about registries and repositories. We typically have at least two different types of repositories. One we call a staging repository. This is where I'm generating images, and an image is basically a gathering of all the code that's needed in order to spin up a container, for example. But I can store other things in the staging repository. I can store identity for my identity management, any secret keys that I need for storing access to databases or encryption keys, all those things. In your staging area, this repository is where you're going to store all the things you need in order to move things into production. Now, it's important. This is key, and we've seen some hacks recently in staging repositories where people inject in the staging repository bogus images that then get carried on into what we call production or golden repositories. This is where these images are locked down, notarized, encrypted. Only things in the golden repository ever get moved to production. Staging feeds into production when it's passed the quality and tests that I would expect it to pass. Staging, I prune all the time too. I get rid of old images that aren't being used, that maybe the container that is described by that image failed all their tests. After some time and debugging's done, I get rid of those images. And production, you want to keep those things around. You want to be able to go back to previous versions as you need to. Policies are different on staging repositories than production repositories. I've seen some organizations have 4 or 5 staging repositories as they pass through different gates of maturity or different gates of passing tests and things like that. They move into the different staging. I've seen silver, bronze, gold, platinum named repositories. Lots of different models out there. Now let's talk about stages. Stages are part of a CI/CD pipeline. Now, the best way to think of stages is that a stage works in a single environment. So if I have a build stage, I may have a build environment. So all of my code is being built. It means that I have policies around that environment. Everything's contained in there. And when all of the steps that are run for that stage have passed, I can put a gate on when things move beyond my build stage, for example. Typically, these are waterfalled very easily. A build happens, it builds clean. Now I'm going to push it on to test. And a test stage works. Now I'm going to push it into a publication stage and then onto a deployment stage. I have seen some organizations that want to streamline this and not put the gates there, and they end up with builds that are run, and then tests are run in parallel with the builds to decrease cycle time. And they chew up tons of resources in test, even though the build ultimately fails. So it's important to define your stages as stopgaps, so that you're not chewing up more resources than you need, but also that you don't have too many stages so that you can't parallelize things and make things run faster over time. So defining your stages in your CI/CD pipeline is extremely important. Now, inside stages, I've already alluded to it, there's actual steps. This is where work actually gets done in building and testing your software. Right? Steps can be run in parallel or in sequence. Lots of tools out there allow you to define this. Most of them have a textual description of this, and some of them even have a GUI for it. Most developers don't want to mess with a GUI. Most developers would rather code it up in some kind of textual format. I suggest doing that because that gives you the ability to actually version control your pipeline and the steps involved in it. This way you can run security checks against your pipeline that make sure that no one's injecting an extra step in your pipeline without you knowing about it. Now that we have all this stuff together, we actually have a pipeline, a real pipeline now. I've defined my stages. I define my steps in each one of them. And I've seen organizations that try and define one pipeline for all of their applications. All their projects that they're building on. And what I have found that typically fails, because either your pipeline becomes so complex with lots of conditionals, or it becomes so restrictive that the projects can't do what they need to. So what I suggest people to do is to templatize what are the major stages that you want, and then let the project take from other people's templates and modify as they need to, as long as they're adhering to your compliance standards that you require and any regulatory that you have. So it's important that each project start as quickly as they can with this build cycle. Don't wait until the end to try and get this automated. You want to do this right up front as soon as possible. And your pipeline can change over time. You will add more tests. You may even add more stages, depending on the maturity of your product. The key here is that you're flexible and that you're version controlling that pipeline. Now, let's talk a little bit more about environments. I said before that most people just create environments instinctually, and they do. I suggest, instead of just doing it kind of ad hoc, create environments. Now, this is where you can really inject your policies around security and compliance across all the different projects. Because a pipeline has to run in an environment, a dev environment or a test environment or a UAT test, performance test environment, whatever they are. If you have a set of environments that are out there, you can inject certain policies in those environments. which includes security, compliance, logging, maintenance, upgrade strategies, anything you can think of that you would normally do in an environment. If you define these up front, then people will use those environments, and you, as a DevOps or security ops guy, you can be able to inject in there what you need to have the service level agreements, quality service, and the security that needs to be guaranteed. Okay, we spent a lot of time talking about DevOps, environments, pipelines, and all that. Let's start talking about the developer. Now, developers tend to work on services nowadays. Even if they're working in a monolithic application, they tend to group their work into a functional unit, which services really are a functional unit when you think about it. We've defined two different types of services before, actually three, application being one of them. A simple service being one, and a complex service being the other. A simple service is something like MongoDB. It's one container that runs. And when I run that container on my laptop, it gives me the functionality I expect to store data in a non-SQL way, in a document. On my laptop, it may only be one container that's running. In a test environment or a dev environment, there could be multiple instances of that service running. And especially in a test environment, I may want to test it in a cluster. So it actually may deploy a cluster of MongoDB services and connect them together. The service is still a MongoDB service. Its behavior changes based off of the environment that it's in. When I run a MongoDB service in production, it probably has audit logs. It probably is encrypted. The configurations are different, but the functionality is the same. So when I'm a developer and I'm developing against a MongoDB service on my laptop, I can write my code, check it in, and be guaranteed that it's going to run okay in production. That's the goal. Now, think of a simple service like MongoDB all by itself is not very useful. I still need them. I need simple services all over the place. But complex services are actually more important. So I can have a complex service like a LAMP stack or a mean stack, or there's lots of stacks out there today. In this case, I have multiple simple services that are running together, acting as basically one service. In the case of a LAMP stack, I've got a database, I've got a business logic service, and I have a front end. Same thing with the mean stack, same thing. MongoDB, Node.js, and any one of the web service frameworks that are out there. So this is bundled together. Deploying a complex service on my local laptop gives me maybe 2 or 3 services, simple service containers that are running, right? It gives me the functionality that I expect so I can write my code, check it out, work it. When I check that code in and it kicks off into the dev pipeline and now it goes into a development area where I'm integrating with other people, that same complex service can take on a whole new different way of doing things. It may have multiple Mongo containers running. It may only have one Node.js. It may have worker.js nodes running. There's lots of different things that can happen. That is based off of the environment policies and the complex service definition. By the time I get into production on this complex service, you can see that I could easily, through security policies on that environment, also attach to that complex service audit logging, security threat detection, cyber threat detection, a bunch of different things that I could attach to that complex service. So anytime that complex service fires up, all those other services are around it that help make sure that it's secure, reliable, and resilient. Now, it's important to understand those concepts of simple service and complex service, because now I have to start defining those as a software developer. I've got to start defining, how do I actually get that stuff to work? Well, there's a couple definitions that are out there. One is called an image definition. These are typically in the container world called Docker images. A Docker file does this. It defines what's in that image. That's a simple container by itself. Now, I shouldn't say simple container. People are starting to use containers for really complex things, but it is still considered a container by itself. Now, when I start talking about service definitions, I include or can include multiple image definitions, but inside there's additional things that are happening. For example, Docker Compose, Kubernetes operators, Helm charts, Terraform, and even CNAB, which are tools that are out there that let me define a service. Now, a service is more than just the container. It's the environment the container is running in. It could include network, storage, or volume connectivity, and it could also include deployment, a number of instances of the container running. So a service really has that configuration so that I can really provision. So when you look at a full service definition, image, configuration, provision, those are the keys. Now, if we put all this together, when a developer is developing a new service, they're not just developing the code for the image, they're also saying the environment that this needs to run in. Now, when I say environment here, I should say the configuration that this needs to run in. It needs a data source. It needs these things. This is where the mesh of your environment and the service definition can come together. And at runtime, it will produce the environment that's needed in order for that container to run effectively and in a repeatable manner, so that I can easily move my code from running on my desktop to running in full production as quickly as possible. Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and do something wonderful.